You know, humanity's story, it's always been written in the stars. Seriously, from our earliest ancestors all the way to today, we've looked up at the night sky and just wondered, what is all that? And what does it have to do with us? It's this incredible journey of wonder, of amazing discoveries, and of figuring out our own place in this massive universe. All right, let's dive in. This quote right here is the perfect launch pad for everything we're going to talk about. It gets at this huge idea that the connection we feel to the stars, it isn't just poetry. It's a real concept, one shared by ancient wisdom and modern science. It kind of suggests our story and the story of the cosmos are really the exact same story. Let's see how that works. For most of human history, our only window to the universe was, well, just looking up. That's it. No telescopes, no satellites, just our own eyes. But you really shouldn't underestimate what our ancestors could see. The patterns they found up there weren't just for telling cool stories. They were fundamental tools for culture and, honestly, for survival.
And this slide just illustrates that perfectly. I mean, we can all be looking at the exact same bunch of stars, but we're not always seeing the same thing. Take the group of stars most of us know as the Big Dipper. It's a great example. In Western traditions, it's part of the Great Bear, Ursa Major. But to the Lakota people, those same 7 stars are the Osetisakowen, the 7 council fires, and they represent the sacred journey of life. So you see, the sky has always been a kind of mirror, reflecting our own cultures right back at us.
And look, this knowledge was deeply, deeply practical. We're talking about basic survival here. By tracking the sun's path, the moon's phases, our ancestors developed the very first calendars. They could predict the seasons, which told them exactly when to plant their crops or when huge herds of animals would migrate. And if you were a sailor out on the open ocean, the stars were your GPS. The sky wasn't just pretty, it was probably the most important tool they had.
But you know how we are. Human curiosity is relentless. Just looking up wasn't enough anymore. We needed to see more. We needed a sharper view. And that drive, that need to get a closer look, kicked off this incredible revolution in technology that would completely change how we see the universe.
So how'd we do it? Well, this timeline shows the amazing leaps we took. We started with these brilliant but pretty simple tools, like the quadrant, which measured how high a star was in the sky, and the astrolabe for mapping where they were. But the real game changer, of course, was the telescope in the 16th century. All of a sudden, planets weren't just little dots of light anymore. They were worlds. And from that point on, it was like an arms race of innovation. Bigger lenses, and even bigger mirrors, all of it leading to the ultimate high ground, putting a telescope in space.
So why was the switch from lenses to mirrors such a big deal? Well, a refracting telescope uses a lens, kind of like a huge magnifying glass. The problem is, if you make a glass lens too big, its own weight will make it sag and bend, and that distorts the light. It's got a physical limit. A reflecting telescope, though, uses a curved mirror, and the genius part is you can support a mirror from the back, which means you can build them to be absolutely gigantic and capture the faintest light from the very edge of the universe.
And this is exactly why getting off the ground was the next logical and totally revolutionary step. A space telescope like the Hubble has an unbeatable view. Up there are no clouds, no city lights, but most importantly, it's above our atmosphere, which is what blurs starlight and makes stars twinkle. Plus, our atmosphere is like a bouncer. It blocks certain kinds of light, like X-rays, from getting in. When you're in orbit, you get the whole, unfiltered, crystal clear picture. It's the best seat in the house.
Okay, so with these incredible new tools, our whole perspective just shifted. The questions got way, way deeper. It wasn't enough to just map where the stars were anymore. Now we could start asking the really big ones. What are they? What are they made of? Where did they even come from?
And the answer begins right here, in one of these, a nebula. I mean, these are some of the most breathtakingly beautiful things in the entire universe, these huge swirling clouds of gas and dust. But they're way more than just pretty pictures. They are, quite literally, stellar nurseries. Every single star you see in the night sky, yeah, including our sun, was born in a place just like this one.
So, what's the recipe for a star? Well, it all starts with gravity. Something, maybe a shock wave from a nearby exploding star, gives a clump of this gas and dust a little push, and then gravity just takes over, pulling everything in tighter and tighter. As it all collapses, the core gets incredibly hot and dense, and it starts to glow. That's what we call a protostar. The pressure keeps building and building until, boom, the core gets so hot that nuclear fusion kicks in. And that is the moment a star is born. It switches on.
Now, what's so wild is that a star's entire life story is pretty much decided the second it's born, and it all comes down to one thing: its mass. Low-mass stars, they're the marathon runners of the universe. They sip their fuel slowly and can shine for 100 billion years or more. Medium-sized stars, like our Sun, they get about 10 billion years. But the heavyweights? Oh, they live fast and die young, ending their lives in a spectacular, universe-altering explosion.
And just to give you an idea of what we mean by heavyweight, let's talk about the supergiant star Betelgeuse. The scale here it's just almost impossible to wrap your head around. If you were to swap our Sun with Betelgeuse, it wouldn't just swallow Mercury and Venus and Earth, it would swallow Mars too. Its outer edge would reach almost all the way out to Jupiter's orbit. We would be living inside of it. That's the mind-boggling scale we're talking about here.
So for thousands and thousands of years, we just watched from the sidelines. But in the 20th century, all of that changed. We stopped just looking and we started going. We built these amazing machines that could actually leave our planet, and we sent them out as our ambassadors, our messengers, into the solar system and even beyond.
A perfect example of this shift is the Pioneer 10 and 11 missions back in the 70s. Now, their main job was to get our first good up-close look at planets like Jupiter and Saturn, but their journey didn't stop there. Right now, as we speak, they're on a one-way trip heading out of our solar system, just coasting silently through that vast, empty space between the stars.
And bolted to the side of each of these probes is this thing, the Pioneer plaque. It's basically a message in a bottle, but we've tossed it into the cosmic ocean. It's meant to be a universal hello. It shows a man and a woman, a map of our Sun's location based on distant pulsars, and a little diagram of our solar system that points a tiny arrow to the third planet. It was our first real attempt to say, hey, we're here, we exist.
Which, it brings up this really wild question for all of us. Just imagine you were on the committee today, designing a new plaque. What would you even put on it to represent all of humanity? What single image or sound or equation could possibly capture our art, our music, our science, our conflicts, our triumphs, the whole shebang? It's a heck of a question to think about.
Okay, let's bring this whole amazing journey full circle now. We started with how ancient people saw their own stories reflected in the stars. But now we're going to see how science has shown us that we are, literally, made from the stars themselves.
Hey, remember how those really massive stars end their lives in that massive explosion we call a supernova? Well, it turns out a supernova isn't just an ending. It's a powerful, incredible act of creation. The insane energy and pressure in that explosion is pretty much the only place in the universe that can forge all the heavy elements that are absolutely essential for life.
And here it is. This is the most profound connection of all. All those brand new elements get blasted out across the galaxy. They seed the next generation of nebulas, which form new stars and new planets. So that means the iron in your blood that's carrying oxygen right now, the nitrogen that's in your DNA, the calcium in your bones, every single one of those atoms was forged inside a massive star that lived and died billions of years before the Earth was even born.
This is what the legendary astronomer Carl Sagan meant when he said these famous words. It's not just a beautiful, poetic thought. It is a literal, scientific fact. We are star stuff. We are the children of cosmic explosions. In a very, very real sense, we are the universe becoming aware of itself.
So think about it. We've gone from reading our myths in the constellations to reading their chemical makeup with giant telescopes. We've gone from using the stars to navigate our little oceans here on Earth to sending our own probes to navigate the space between them. Our perspective has expanded from a tiny patch of ground to the scale of the entire galaxy. So the question isn't just what's out there anymore. It's where do we go next in this incredible cosmic story that we're all a part of?